Hi guys, so today we'll be solving this problem called open the lock. Let's read it. You have a lock in front of you with four circular wheels. Each wheel has 10 slots 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The wheels can rotate freely and wrap around. For example, we can turn 9 to be 0 or 0 to be 9. Each move consists of turning one wheel, one slot. The lock initially starts at 000, a string representing the state of the four wheels. You are given a list of dead ends meaning if the lock displays any of these codes, the wheels of the lock will stop turning and you will be unable to open it. Given a target representing the value of the wheels that will unlock the lock, return the minimum total number of turns required to open the lock or -1 if it is impossible. Okay, so we've been given a certain dead ends, which is a vector. Now these dead ends are basically the uh, stoppage which you have if the combination of the locks come to that particular string, then we stop turning and we are unable to open it, and therefore we return -1. Okay, we can't take. Okay, so for example, if I try all of the combinations and I'm still not able to get any answers, then I'll return -1. But if I'm getting one of the dead ends, then I'll reiterate and try to get another combination such that I get my target. Okay, so these are the dead ends which indicate that we do not need to go on these. If we go on these, then we need to come back on the initial states. So how we can solve this problem is by thinking of it as a tree. So a tree starts with 000, which is the root node, and then it goes to the leaf, which is the target, and we get the different combinations of the leaf is one of the targets that we need. So therefore, we'd be thinking of it as a tree, which is having its leaf as the target, and one of the combination of the leaves is the target. So we'll be doing it by BFS, which is breadth first search, which is like at every level we'll be finding the combination of strings which are, if added, what would they give, and if subtracted, what would they give. So it will give us two states, which is the state which is ahead of the current number and a state which is behind the current number, which can be done by adding +1 to any of the digits and -1 to any of the digits. So let's code this and it will be more clear. So what we'll be doing first is by just maintaining a set for dead ends. So dead ends begin. So I have created a set because we can get duplicate items, so we wouldn't want that in the dead end. Then I'll also be creating a visitor. Okay, string visited. So all the strings which will be visited will be stored here, and as we are doing BFS, so we'll need q. So string q. Now uh, I initialize one of the states, which is the starting state, which is 000. So string initial is equal to 000. Now if we find initial is not equal to dead ends, okay, if it is not equal to dead ends, okay, so that means we have found the initial state in the dead ends. That means we cannot go ahead because dead ends means you can't take that state, right? So therefore we'll return -1. This will be the base condition that we need to check first, which is an edge case. Now after this we'll just simply put the initial in the queue as well as in the visitor. Insert initial initial. Okay, now after this what we'll be doing is that we'll simply do the Bfs traversal. So which is just by checking if queue is empty or not, and then taking the size of the queue, then iterating through every level. Okay, so for that, queue size would be the level. Now we take out a variable, uh, we take out the front of the queue, sorry, and then we do queue dot pop. We also have your string result, which is equal to 0. Now queue dot pop, if um, t is equal to the target, which is if we found the element, then we return the result, which is the result would be counting the okay, it should be int. Okay, the results would be the count, would be counting the number of different combinations of strings that we need to take, combination of numbers that we need to take. So if we found the combination that we need, which is the target, then we return the result. Otherwise, uh, we call this function called neighbor. We create a vector of strings, which is neighbor nodes is equal to get neighbor nodes, where I'll be passing t. So get neighbor nodes basically gets the neighbor nodes of that particular current string, which is by adding one or subtracting one to all of the different elements on it. So that will be getting us a vector of string. Then we'll run through that. So auto node in neighbor nodes. In this, what we'll be doing is that we'll be checking if deadends dot find node is equal to deadends end, which means if we haven't found the dead end, we haven't found the node in the dead end, and as well as visited of node is equal to visited of end, visited dot find. Okay, so if these two conditions are satisfied, then we simply push it in the queue, and also we insert it in the visited array or set. Okay, now after this, everything would be completed. Now when it comes out of the for loop, at that time we have this particular count loop. Out of that, we'll come out and we'll be simply increasing the result, because that is the combination for that particular level. Now we'll be finding for the next level. Then out of this, we'll simply return -1. Now let's go to the get neighbor function, which is getting us the neighbors for that but current node. So vector string get neighbor nodes, and we have string key. Now I'll be creating a vector string of result for storing the result. Then I'll be looping through every element, every number in that particular combination. Okay, and I'll be creating first a temp is equal to key, and first what I'll be doing is adding. So I'll be adding key of I minus 0 plus 1. Okay, this will add one element to it, and percentage, because we need to see that 9 becomes 0, or maybe if it increases more than 9, then it comes back to rounding off to 0 or more. Okay, so that will be doing plus 0 for making it into the string. Then result dot push back temp. Now we'll also be subtracting that particular element. So key minus 0 minus 1 plus 10 and percent 10 plus 0. So this will basically subtract the element from the temp, and we'll be putting all of this into the result string, and then from here we can return result. Okay, so what we did here is that we first created a dead ends vector set which basically stores the dead end so that we don't have any duplicates. Then we have created a visited and a queue for traversing through the tree or the graph, whatever you call it, different combinations of that particular number. And then we check if dead ends is having 000, which is our initial state. If it is having, then we return -1 because we can't go ahead of that. Then we iterate through every level, which is Bfs Traversal, where we go through every level and we found that what is the front of the queue. If it is equal to the target, then we return the result. Otherwise, we check its neighbor and we go through its neighbor and push it into the queue and visit it as well. And then we increase the result because that is the number of combinations that we need to get to the result. And then finally we'll go again throughout the loop and until we find the front as equal to the target. Okay, so let's run the code to see if everything is working fine. Yeah, and that is accepted. So I hope you guys understood the problem. Do solve it and do subscribe to my channel and like this video and share this video. Okay, and thank you.